Hey guys, welcome back. This is part 2 of the law of sine video. So I'm showing you this screen once again just to let you know that all the rules in the notes that we spoke about on last video will remain the same. In this next video we're going to work on problems that you end up having to find the angle first. So for that reason you're going to see me using this version of the formula here. So again, since we're looking for the angle, I'm going to be putting the angle part of the formula on the numerator up on top. Okay? Alright, so before we can go and solve a problem, let me show you what changes are going to happen here. So again, this is law of sine, finding an angle first. In your textbooks, you might see the words the ambiguous case. Honestly, it's called the ambiguous case because it takes a little while to solve at times. There's a possibility of having a second triangle. So we've seen in the last chapter working with a right triangle. We did SOHCAHTOA and Pythagorean theorem. We saw in the last video working with a triangle that is obtuse, meaning not right. Two scenarios that you haven't seen that you will see in this video is a no triangle where one of the sides may be too short or the angle is too wide in order for it to close. Or you may see a scenario of two triangles. This is the one that takes a while. All right, so your chart, whenever you have to find the angle first, is going to be a little bit longer. You're going to set up the possibility of having two triangles. Once you get the hang of this, you might be able to fast forward through this a bit, but for now we are going to set up if two triangles do come out. All right, so to start off with our notes, like I said, in these problems we will have to find an angle first. Once you do that, let's say we are looking for big B first, okay, for argument's sake. Once you find that angle, you're going to subtract that angle from 180 degrees. The reason you're doing this is because that number that you get will give you what B2 is, what that angle would be in the second triangle. Okay? If that angle happens to come out So we begin these problems by creating two charts. The question will give you three givens, and those three givens will be the same for both triangles that you set up. Let's say, for example, that we have to find big B first. Okay, we will do the same procedure as last video. I'll show you now when it comes to an example. And once you find this B, you're going to get that number, and you're going to subtract it from 180, and that number is going to give you what the big B would be in the second triangle. All right. Your next step is to complete the 180 rule for both triangles. Now, if, let's say, for example, you're finding the big C for both with the 180 rule, if one of those were to come out negative, let's say this one comes out negative, then this entire triangle does not exist and you just continue working with this one. If they both come out as positive numbers, then all you have to do is complete the procedure like if you were solving two separate problems and finish each of the charts. All right, so here we have example number 1. This blue triangle is what would be given in the question. So I took the liberty and I set up these two charts. I have triangle 1 marked in orange and triangle 2 marked in green. Go Canes. So I took the given information and I set it up into both. Remember that the given information will be the same in both triangles. So let's work with triangle 1 first. If I look at triangle 1, I can see that I have a match with letter A. So just like last video, I'm going to set up the formula and compare it with C. But because I am looking for angle C instead of side C, I'm going to set up the formula with the angle part on top. So I'm going to say sine of C divided by 12 equals sine of angle A, which is 81 degrees, divided by 20. All right? Now, I want this numerator by itself because I want to start getting that C alone. So what, oops, sorry about that. So what I'm going to do is I'm going to take this 12 and multiply it over to the other side. So this would read sine of C equals, I like to put my 12 up front to make sure my calculator doesn't accidentally get multiplied with that sine of 81. And then we divide all of that by 20. Now we're not quite done yet. There is one more step here. I do want to get this C by itself. So hopefully you remember from last chapter, the way we get this angle by itself, we do the inverse operation. So we would say C equals inverse sine of this fraction here. So let's get our calculator out. Remember, we want to be on degree mode. And all I'm going to do is press inverse sine. So let me move this up real quick. A reminder that our inverse button is right up here in blue. So I'm going to press second sine. And now I want to put that fraction in. So my fraction button is alpha y equals n over d. Now I can type in that 12 times sine of 81 all over 20. And I can press enter. So my angle C is 36.34 degrees. In my class, I tell my students they can round degrees to whole numbers. So C is 36 degrees. Now remember, this was all for triangle 1. So this is C1 that we're talking about right here. And I'm going to go ahead and fill that in. Our next step is to get that number and subtract it from 180 to find what C2 would be. So I'm going to say 180 minus 36, and this gives us 144 degrees. This is to find C2. All right, our next step is going to be to complete the 180 rule for both of them. Okay, so let's set up here for triangle 1. I'm going to say 180 minus, we have 81 degrees minus 36 degrees. All right, this gives us 63 degrees. And we can go ahead and plug that in. That did not give us a negative number, so we know for sure that triangle 1 will work. Okay? Next, I'm going to come back over here as I worked on triangle 2 over here. For triangle 2, we can say 180. I'm going to subtract downward here just so we can see it. Minus 81 minus 144. Now, those of you with your mental math can probably see that this is going to be giving us a negative number, and it gives us negative 207. Negative 207. Because this gave us a negative answer, triangle 2 does not work. Okay? So now that I've determined that triangle 2 does not work, all I have to do is finish solving for side B. Okay? So I can set up. Now I'm looking for the side first, so I'm going to put the side on the top over sine of 63 equals, I can use A or C, but I'm going to choose to use A because that's the one that was given. So I'm going to say 20 over sine of 81 I want to isolate that b, so this is going to come and multiply over to the top. And this will say b equals 20 times sine of 63 degrees all over sine of 81 degrees. We're going to go ahead and plug that in. Alpha y equals, for our fraction button, 20 times sine of 63 over sine of 81. And we have that little b is 18.042, and we were talking about inches in this problem. And again, this is for B1. We have 18.042 inches. And we are done with this problem, okay? Here's the only extra step you might have had to have taken. If this angle here had not come out negative, all we would have had to have done is this step one more time for little b2, and then you would have completed both triangles. Gonna pause for a moment just to color code for those of you who like to color code your notes. All right, and there you have it color coded. Feel free to pause the video at any time. All right, here we have example number 2. So here in blue is our given triangle, and again I've set up our two charts according to the given information. So starting off with triangle number 1, we see we have a match with A, and we can use it to compare with B. We are looking for angle B, so I'm going to set up my formula with the angle on top. Sine of B over side B, which is 15, is equal to, I'm going to compare it with A, sine of 69 over 12. I've got a little secret for you. This is going to be a nice quick problem. Our calculator is going to give us a nice hint as to what to do. So let's keep moving. We want to isolate that b, so I'm going to multiply this 15 over. And now I have sine of b is equal to 15 times sine of 69, all divided by 12. And again, I want this capital B by itself, so I'm going to do the inverse operation, which would be inverse sine of this entire fraction. So let's see here what happens when we go to our calculator. All right. I'm going to do second sine to put the inverse, and then alpha y equals for the fraction button, 15 times sine of 69, all divided by 12. Now, my calculator is telling me domain error. Okay? Whenever you have a domain error when you are solving triangles, it means that this angle does not exist. So I like to put a little DNE for does not exist. This, if you remember the third image I showed you at the beginning of this video, is a scenario where neither of the triangles exists. This is called a no triangle. This is everyone's favorite example because it's done real quick. And believe it or not, that's it for this question. All right, last thing for this video, finding the area of a triangle that it is oblique. All right, so let's look over here where I wrote down the formulas. I know it looks like there's 3, but in reality they are all the same formula. It all depends on what's given. So you will be multiplying half times the two sides that are given times sine of whichever angle is given. Now this formula does only work when the angle that's given is in between those two sides. All right. So in this case, let's look at this example. Angle A is given, so we will be using the one with angle A, the first. Okay. So my work will be half times the two sides, so times 5 and times 6, and then times sine of the angle that's in between, times sine of 71 degrees. Plug that in your calculator and you get 14.182. And that is the area of this triangle. Now, a quick little insider. You may recognize that the majority of this looks like the area of a triangle that you learned back in middle school. Half times base times height. The only thing we add, because this is not a 90-degree triangle, is this portion right here that is sine of the angle in between. All right. Have a good one, guys.